Okay. Bismillahirrahmanirrahim. We'll continue. We'll finish this problem. Then we'll do more examples, and then I will go to all the exams questions, which I think it doesn't need too much calculation since it will. I mean, I need to do only one eigenvector, something like this. Let us see what will happen. Okay. Find the eigenvalues and eigenvectors for this. So I need to do a minus lambda I, the determinant. 1 minus lambda 2, 2 minus 2 minus lambda. You have lambda square, 2 lambda minus lambda plus lambda. Yeah. Minus 2 plus 4. Minus 2 minus 4, sorry. That will be lambda square plus lambda minus 6, which is lambda plus 3 times lambda minus 2. So I have lambda minus 3 and 2. Let's find these are the eigenvalues. Okay. Now for lambda equal minus 3, I need to find the eigenvector. I have what? 1 minus, that will be 4, 2. 2. Minus 2 minus minus 3, that will be 1. Yeah, I let P1, K1, K2. I need to solve this. A minus lambda I V equals 0. 0, 0. So I have this equation, these two equations. Actually, they are only one equation. 2K1 plus K2 equals 0. Multiply the second one by 2, I'll get the first one. So I'm getting K2 minus 2K1. So K1 free variables. You can do it the other way, the way you like. So I let K1 equal 1. K2 will be minus 2. I need only the eigenvalues and eigenvectors. So I have 1 and minus 2. That will be P1. So now for lambda equal to, what I will get, I let V2, K1, K2, and I need to solve this system. So I have what? 1 minus 2, that's minus 1, 2, and I have 2, minus 2, minus 2, minus 4, times K1, K2. It seems I have two equations, actually they are only one equation. Multiply the first one by minus 2, you get the second one. So I have K1 equal to K2. So K2 free variable. So I let K2 equal 1. So K1 will be 2. So my second eigenvector will be, or the eigenvector for lambda equal 2, it will be what? 2 and 1. So I have this and I have this. Now let me do this. Wow, it seems to be a little bit complicated. Then I have to these are easy ones, okay. So I need A minus lambda I. That will be what? 1 minus lambda, 2, 1, 6 minus 1 minus lambda, 0, minus 1 minus 2 minus 1 minus 1. Wow, that will be 1 minus lambda. What is this? What is the remaining? Minus 1 minus lambda, 0, minus 2 minus 1 minus lambda. Okay. Minus 6. Take this and this. I have 2, 1, minus 2, minus 1, minus lambda. Minus 1. Take this and this. 2, 1, minus 1, minus lambda, and 0. So what I have? 1 minus lambda. Here I have what? Lambda square. Okay. Plus lambda. Plus lambda. And plus 1. minus 0, so it's 0. Minus 6, I have what here? Minus 2 lambda minus 2 plus 2. Okay. Yeah, minus 2 lambda plus 2. Yes. Minus 1 times what? 0, 1 plus lambda. Okay. Open the brackets. I have what? I don't have common factor here. I can take. This is cancelled. Okay. So that give me what? Minus lambda cubed square. I have minus lambda square plus lambda square gone. I have minus lambda plus lambda gone. And I have plus 1. Okay. Plus 12 lambda minus 1 minus lambda. So this is cancelled. So I can take minus lambda common factor. I have lambda square minus 12 lambda plus 1. Plus 1? No. This is, and take minus lambda common factor. Yeah, there is a mistake somewhere. 1 minus lambda 2, 1. 6 minus 1 minus lambda 0 minus 1 minus 2 minus 1 minus lambda. I have 1 minus lambda, the rest, good. Minus 6, the rest, good. Minus 1, the rest, 2, 1, minus 1, minus lambda. Okay. So I have 1 minus lambda times what? Lambda times lambda square. Lambda plus lambda. No, this is plus 2 lambda, sorry. Yeah. Then I have plus 1. Yeah, this is plus 2. So I have what? Minus lambda cubed. I have minus 2 lambda square plus lambda square. That will be minus lambda square. Okay. I have what? 2 lambda minus lambda. That is plus lambda plus 1. Is it? Lambda cube. Lambda square will come from where? 1 minus 2 minus lambda square. Lambda will come from where? Minus lambda plus 2 lambda plus lambda. Yes. And this is plus 12 lambda minus 1 minus lambda. That will be minus lambda cube minus lambda square. This is cancelled. And this is cancelled plus 2 plus 12 lambda. Now I can take minus lambda common factor. Let me do it here. Minus lambda common factor. I have what? Lambda square minus lambda plus 12 minus lambda. Lambda minus 3, lambda minus 4. So lambda 0, 3, 4. These are the eigenvalues. I can check. Their sum is what? I have 12. Is it plus 12 or minus 12? That will be, I took minus common factor. Yeah, I took minus common factors. I have minus lambda. The remaining is lambda square. This will be plus lambda minus 12. Yeah, that will be minus lambda I have lambda plus 4, lambda minus 3. 0, minus 4, 3. Add them minus 1. Add this, trace, minus 1. So this is the way to check, especially if it is a linear calculation. So now I am okay. Now for lambda equals 0, I need to do the eigenvectors. Let V1, K1, K2, K3. I need to solve this. So I have what? 1, 2, 1, 6 minus 1, 0, minus 1, minus 2, minus 1, times K1, K2, K3 equals 0, 0, 0. I need Gaussian elimination. Yeah, I think we'll do it. So I have what? 1, 2, 1, 0, 6 minus 1, 0, 0, minus 1, minus 2, minus 1, 0. So multiply by minus 6 and add it to the next one. That will be 0. Minus 6, that will be minus 13. Okay. Minus 6, that will be minus 6. And this is 0. Multiply by 1 and add it. Multiply by 1 and add it. Multiply by 1 and add it. This is 0. That's it. Yeah. So I have what? K1 plus 2K2 plus K3 equals 0. And I have minus 13 K2 minus 6 K3 equals 0. So I have from here K2 will be equal to what? 6 over 13 K3 minus 6 over 13 K3. Okay. And from here, I have K1 will be equal minus 2, that will be 12 over 13 K3 minus K3, which is minus 1 over 13 K3. So K3 is a free variable. Let K3 equal what? 13, I think, better. So I have K2 equal minus 6 and K1 minus 1. So it will be my eigenvector minus 1 minus 6, 13, which is this for lambda equals 0. I need more space to find the other two. They are just calculation. So for lambda equals what? Minus 4. Let me see what will happen. I did V2 and I need to solve this system. Minus 4. So you have 1 minus 4. That will be minus 3, 2, 1. Good. Minus 1 minus 4. That will be 6, 3, 0. Minus 1 minus 2. Minus 1 plus 4. That will be 3. 1 minus 4 minus 3 minus 1. 1. Sorry. It's lambda is what? Minus 4. So I have 1 minus 4. That will be 5. 5, 2, 1. Then I have minus 1 minus 4. That is 3. Minus 1 minus that will be 3. Yeah, that will be the correct one. times K1, K2, K3 equals 0, 0, 0. So I'll do Gaussian elimination. Very clear, I will make the third one, make it the first one. 0, 0, 0. Multiply by 6, add it. That will be 0. By 6 and add it, that will be minus 9. Okay. By 6 and add it, that will be 18. 0. By 5 and add it, that will be 0. By 5 and add it, that will be minus 8. By 5 and add it, that will be 16. Divide by minus 9. That will be 0. 1 minus 2, 0. Divide by minus 8 here. Have 1 minus 2, 0. So that gives me 1 minus 2, 3, 0, 1 minus 2. That will be 0, 0, 0. Yeah, multiply by minus 1 and add it. Minus R2 plus R3. So we have what? K1 minus 2K2 plus 3K3 equals 0. And I have K2 minus 2K3 equals 0. So K2 equal 2K3. Plug it here. I have K1 will be what? 2K2 minus 3K3. That will be K3. That will be, it's 2K2 plus 3K3. That will be 2K2 okay. It's minus 1, sorry. This is minus 1, minus 1. So this is minus K1. Okay. So K1 will be 3K3 minus 2K2. That will be minus K3. So K3 is a free variable. So let K3 equal 1. What will be K2? 2. And K1 minus 1. So my V2 will be minus 1, 2, 1. Which is the same as this one. Yes. Yeah, I need to be careful with the calculation. Yeah. For lambda equals 3, I need V3. I need to solve this system as usual. This will be one. Okay. Yeah, so what is the system? 1 minus 3. That will be minus 2, 2, 1, 6. Minus 1 minus 3. That will be minus 4, 0. And then I have what? Minus 1 minus 2. Minus 4. So try to do Gaussian elimination. Same idea. Yeah. I will take this one to be the first row. And this is 6 minus 4, 0. Minus 2, 2, 1. This is minus 1, minus 2, minus 4, 0. Multiply by 6 and add, that will be 0. 6 and add, that will be minus 16. 6 and add, that will be 24. And this is 0. Okay. by minus 2 and add, that will be 0. By minus 2 and add, that will be 6. By minus 2 and add, that will be 9. That will be 0. Mistakes. Minus 1. The last row. Minus 1, minus 2. Minus 1, minus 3. That's minus 4. 6 minus 1 minus 3. That is minus 4. This is 1 minus 3. That is minus 2. 2, 1. Okay. Multiply by 6 and add. That will be minus 16. Multiply by 6 and add. That will be 24. Multiply by 2, by minus 2, and add. That will be 0. By minus 2 and add. That give me what? Yeah, it's okay. Correct. Yeah, I think everything is correct. Now, I divide here by what? By 8. Yeah, it's Gauss animation. You need to find better ways to do it. Divide by minus 8. Let me divide by minus 8. I get what? Divide by minus 8. I get 2 here. By minus 8, that will be minus 3. 0. Here I divide by 3. Divide by 3, I get 2. There is a minus sign. Minus 1, minus 2, minus 4. Is it the same correct equation? Minus 1, minus 2, minus 4. Minus 2, 2, 1. And 6 minus 4, 0. Okay. What is the eigenvalue? Lambda equals 3. Correct. I have multiply by 6 and add. That will be 0. 6 and add. That will be minus 12, minus 16. 6 and add, that is minus. Yeah, so that will be plus 3, and that will be 3. Yes. I should have infinitely many solutions at the end. So I have minus k1, minus 2k2, minus 4, k3 equals 0. And I have 2k2 plus 3, k3 equals 0. So this give me k2 is minus 3 over 2k3. So for sure I will take k3 to be 2 or minus 2. Okay. Now plug it in the first one. So I have k1 will be what? Minus 2k2 minus 4k3. And that give me what? K3, that will be 12 over 2, that will be 6, that will be 4k2. I want it to be in terms of the other way. Minus 3. What was that? 2. Okay. So minus 3 here. I have what? K1 is minus 2k2 minus 4k3. So k2 is minus 3 over 2k3. So plug this one here. I have minus 6 over 2. We have minus 6 over 2. 6 over 2 give me what? 3. So I have minus K3. Yes. Yes. So K3 is a free variable. So I let K3 to avoid fractions. I let K3 to be minus 2. So it will be K2, 3, and K1, 2. So my third vector will be what? 2, 3, minus 2, which is this one. Sorry, but calculations, yeah, sometimes it's very complicated. Yeah, this is 2 by 2, so I think I can do it quickly. I have what? 3 minus lambda, 4 minus 1, 7 minus lambda. So I have lambda square, minus 11 lambda, minus 10 lambda, plus 21, plus 4. So it's lambda square minus lambda plus 25, which is lambda minus 5 square. So I have lambda is 5 and 5. So eigenvalues, these are the eigenvalues, which is 5 of multiplicity 2. Now for lambda equal 5, I have to check the eigenvectors. I need to let V1 or V, K1, K2, and I need to solve this, which is what 3 minus 5, that is minus 2, 4, minus 1, 7 minus 5, that's minus 2. For sure, these two equations should be the same. Which is very clear. Multiply the second one by 2, I get the first one. So I have here, this it should be plus 2. 7 minus 5, that is plus 2. So now they are the same. Okay, so K1 will be 2K2. So K2 free variable. So I let K2 to be 1. What will be K1? Will be 2. So it is the eigenvector. I have only one eigenvector, which is 2, 1. And that will be my answer. This one, A minus lambda I. That gives me what? 6 minus lambda minus 1. 5, 4 minus lambda. That gives me what? Lambda square minus 4 minus 10 lambda plus 24 plus 5, which is lambda square minus 10 lambda plus 29 equal to 0. I cannot factor it. I can do the quadratic formula. That will be 10 plus or minus square root 100 minus 4 times 29 over 2. So what's 29 times 4? 36, 116. That will be 10 plus or minus square root of minus 16 over 2. That will be 10 plus or minus 4i over 2. That is 5 plus or minus 2i. I'll do lambda for one of them. 5 plus 2i. These are the eigenvalues, by the way. For this, I need to do the calculation. Let V will be K1, K2. I need to solve this system. What I have? 6 minus 5 minus 2i, so it's 1 minus 2i minus 1. I have what's in the other one. This is 5. 4 minus 5, that will be minus 1 minus 2i times k1, k2 equals 0, 0. For sure, I have these two equations where they are the same. How to show they are the same? Yeah. I'll multiply the first equation by 1 plus 2i. So multiply this one just to show you they are the same. So check this. 1 minus 2i times 1 plus 2i. That will be what? X minus y times x plus y. That will be 1 minus 4i squared, which is 5. That give me 5k1 which is the second equation. So I have only one equation, so I will write k2 is equal to 1 minus 2i k1. Okay. Or just to make it like what he did, or I can use this one to write k1 equal 1 plus 2i over 5 k2. And this is what he did. So now k2 is a free variable. Both are correct. Do it the way you like. So I let k2 equal 5. What will be k1? 1 plus 2i. So v1 will be what? 1 plus 2i with 5. This is associated with lambda equal 5 plus 2i. Now for lambda, 5 minus 2i, no need to waste time. Right away, v2 will be v1 bar, and that equal 1 minus 2i 5. Which is this one? This is this one.